Welcome to another video in this series, and this is the last video in this series of Azure Network Specialist AZ 700. And today we are wrapping it up with Network Watcher. Well, as of now, we have talked almost all the topics in the syllabus. But if you see anything which is not discussed in this playlist, you are feel free to leave me a comment and we'll see about it. As per my understanding, we covered all the syllabus as per MS Learn, all the topics. All right, so let's start with Network Watcher. If you are new to Azure networking and wondering how to monitor, diagnose, and troubleshoot your network traffic, this session is for you. Now, just to understand and make a relatable analogy, let's make it a little fun. Imagine you are in charge of a running busy airport. Okay, running busy airport. All right. Now, flights taking off and land every seconds. What is taking off? Flights are coming in, flights are going out. So these flights are taking off or landing, or these flights are just take off, right? These are our flights. Now, how exactly it happens on the airport? If you just think about it, like there's or like the international airports, there are thousands of flights are coming in and going in, and it is pretty smooth. So for that, you have something called air traffic controllers, right? So that's how it manages the traffic. Now, just think about it. Your traffic controller would be our network watcher, okay? Network watcher. And what exactly the network watcher watches? It watches data and how the data moving moves in the form of data packets. Okay, so flight could be as data packets, and inside the passenger, the inside we have passengers. We can say it's data. So network watcher is watching the data moving in, moving out as a data package, just like this particular analogy. This is just for our new friends who are new with this Azure thing or public cloud. Now let's dive into it. Okay, let's dive into it technically. So we can say Azure Network Watcher is a tool in Azure that helps us monitor and diagnose. Okay, monitor and diagnose network related issue. That's the reason we are only talking about Network Watcher. We have talked about Azure monitoring. This is also part of Azure monitoring. Azure monitoring is a bigger umbrella, but this is AZ700. So we are focusing on Network Watcher. So what it does, it monitor, diagnose, and also help these things in troubleshooting our network related issue. So in order to understand all this, let's make a simple scenario. We have two virtual machines. Okay, one is our web server, another one is our database. Let's make it very simple. Okay, web or app, and we have also database. Okay, this is our database. Okay, this is our database, which is a three-tier application, and we find it everywhere, right? It's pretty normal. This is pretty normal, right? This will help us understand how exactly Network Watcher helps us. So now, if you have multiple virtual machines, databases, applications running in Azure, you will need a way to check if they can communicate properly, detect failures, and optimize traffic flow, because these are talking to each other, right? This will request to the application, application will talk to the DB, and then in response, this will send the requested data, and it will send the requested response to the web request. Okay, all this is happening. I'm creating one guy here who is trying to access, which will make everything simple to understand. So where exactly it is helping us? It is helping us here, whether they are able to communicate properly, or if there is any failures, it will help us to detect failures. And if there is a latency performance issue, then it will help us optimize the traffic flows. Now, think of Network Watcher as a CCTV system for your cloud network. It watches every connection, records events, and even helps you investigate problems when something goes wrong, which means Azure Network Watcher provides a suite of tools to monitor, diagnose, view metrics, and enable or disable logs for Azure IaaS resources. Yes, this is for IaaS resources. So Network Watcher enables you to monitor and repair network health of IaaS products like virtual machine, virtual network, app gateways, load balancers, etc., etc. Right. Network Watcher isn't designed or intended for PaaS monitoring or web analytics like Azure SQL database. So when you create or update virtual network in your subscription, this network watcher is automatically enabled in your virtual networks region. So if you have this Azure, there is no network watcher here. Let's suppose this is a subscription, or maybe you have created Azure SQL database, right, which is a PaaS service. So there is a no virtual network. So there is a no network watcher. But if you create a virtual machine, all right, or if you create a VNet, right, anything IaaS, VNet, then automatically this network watcher instance will be created in the same region and help you monitor and diagnose your network related issue. Okay, this is something good to understand. Now let's remove this. Now let's explore the main part of network watcher. As of now, we were just trying to understand what it is. Okay, and we have a pretty good and decent idea what it is. Now we are exploring the features. Okay, the very first feature is connection monitor, what it offers us. Okay, how exactly this network watcher, what network watcher offers us, and how exactly it will help us monitor and diagnose and troubleshoot the network related issue. For that, it has multiple features or options that we have. The first one is net connection monitor. So let's say you have this web server right here that connects to a database server. If your website is suddenly slow, okay, now connection monitor helps check if there is a connectivity problem between them, between these two. So that's how connection monitor helps. Now let's take another. Let's suppose your web application is slow. Let's explore it further. And you need to diagnose network latency. Okay, I should write here web slow, and we need to diagnose latency, network latency. How exactly it happens? Well, customer starts complaining that the website is slow and sometimes unresponsive. The backend database is on a separate virtual machine. You suspect network latency between the web server and the database. So we use connection monitor here. The network watcher tool, connection monitor, is one of the feature that we have in network watcher. This tool shows the latency in usually high. So between this communication, it will check the latency because customers are calling and complaining about the slow or unresponsiveness of the website. Now, You decide to scale up the web server and migrate the database to the closer Azure region to reduce the latency, because latency is directly proportional to distance, higher latency. So maybe after the change, just for the sake of understanding, connection monitor confirms the latency is back to normal and the websites run smoothly. So that's how the connection monitor helps. So when we use connection monitor and what it is, well, we use connection monitor for continuous tracking of network performance and diagnose slow connections between Azure resources. This is the main important part. Now, what it is a network monitoring tool that continuously checks connectivity between your Azure resources like virtual machines and external endpoints such as another VM, database, or internet resources. How does it help? It helps us providing real time insights into network performance, real time insights about network performance, right? That's how it helps us. It measures latency, packet loss, and network health between the resources. Detects intermittent connectivity issue. Intermittent connectivity issue. Okay. All these things connection monitor can help us. So with all this understanding, if somebody asks you when to use this particular feature of Network Watcher, the answer is pretty simple. Whenever there is a report of website slow or failing connections, okay, website slow and failing connections or unresponsiveness between Azure resources, or to monitor critical connections of web apps, database, and hybrid networks. Okay, in that situation you could go and help of connection monitor. Now how to use it? Well, you need to open your Azure Network Watcher in the Azure portal, select connection monitor, and you need to click on add. Choose the source and destination, set the monitoring frequency like every 60 seconds, and create start monitoring. I'll show you. So what you need to do, you need to go to the search bar and type network watcher. Select the network watcher. Here, this is our network watcher. Under monitoring tab, you will see topology. It will give you the topology of your environment and the connection monitor that we are talking right now. You choose the connection monitor and click on create. And here you need to provide the information of your source and destination and start monitoring. Okay. And under network diagnostic tools, all these things we are going to talk about one by one. The first is IP flow verify. This is another networking tool that we use under network watcher, which is IP flow verify. Now the name is revealing a lot of things what it could be. Let's try to understand with the scenario where users cannot access a new application after deployment and you suspect maybe a blockage like a firewall issue, right? So this time this is not slow anymore. This time it is, if this guy is trying to access application, okay, what is happening? This guy is unable to access application, okay? And it's simple. Let's see where is the blockage. Now, what is the solution? Well, we use IP flow verify. That's what we are learning right now. So somehow we have to use this because that's what the scenario we have prepared for. So IP flow verify will help us to test whether traffic is allowed or blocked between employee laptop and the Azure VM. Okay, from here to here. This is Azure VM. These are web server. These are all Azure VMs, right? So the test may show that the port 443 is blocked by an incorrectly configured NSG. So you'll modify the NSG rule to allow input traffic on port 443 and employees immediately gain access to the application. So use IP flow verify when troubleshoot blocked connections to quickly identify firewall or NSG rule misconfiguration. So how we use it, we simply provide the IP of the source and destination and we'll see whether there is a communication and if not, who is blocking that. So this is what the IP flow verify is. Now, if we have to define what it is, we can simply say IP flow verify simulates traffic flow. What it does, it simulates traffic flow. Let me make it black. Between whom? Between source and the destination. We will provide the source IP and the destination IP or destination resource information to check whether a specific connection is allowed or blocked by NSG or firewall. So how does it help? It quickly identifies blocked traffic due to misconfigured NSG or firewall. Help us in identify blocked traffic. Let me make identify. Right, it helps. So helping us in troubleshooting saves time by pinpointing the exact rule blocking the traffic. It will not say the NSG, but it will show you what NSG and what rule you need to modify. So when should we use it? Whenever we have an issue like when an application or service isn't accessible over the network, like allow and block issues, right? That's what we're doing. So before deploying new firewall or NSG rules to test connectivity impact, we could utilize this and check. All right, so how can we use it? Again, we need to go to the network watcher. Here we have IP flow verify, and we need to choose the source and the destination, protocol and direction. Remote IP address is the source, destination is Azure virtual machine, and when we click the verify IP flow, it will say whether the connection is allowed or it is blocked by XYZ rule. Very well. Now let's take packet capture. Okay. Now let's try to understand this. Sometimes you need to look inside the network traffic to see what's really happening. This is where packet capture helps. It records network packets traveling in and out of a VM for deeper analysis. Think of it like a CCTV recording of your internet traffic. If something suspicious happens, you can go back and check the footage. Right? So, in order to understand this, I think we should take another scenario which will make more sense to us, right? Okay, then let's take a scenario. Let's say users report intermittent issue with an Azure hosted application. Now, these guys trying to access the application, and this time they are talking about intermittent issue. Sometimes it works, sometimes it doesn't. Intermittent. So a web application hosted on Azure Virtual Machine works fine for most users, but some users or some customers report random page load failures, intermittent issue. And regular network monitoring doesn't show any dropped connections. That's the region we want to capture the packet, which will show us what is happening. So use packet capture to record network traffic between the web server and the user. And what would happen? We will discover that the issue only affects users from a specific region. This is just for the example. Now, packet capture will help us identify that. So after analyzing the packets, you find that an external DDoS attacks is flooding your application with requests causing some legitimate user requests to fail. So you enable Azure DDoS protection and implement rate limiting on the application firewall. So what's the lesson here? Use packet capture for deep analysis of network traffic when diagnosing intermittent or hard to reproduce issues. Okay. Now with this scenario, with these examples, let's try to explain packet capture. What is it? Well, packet capture record the live network traffic. Okay, live network traffic on an Azure VM for deep analysis. It captures packets entering and leaving VM for security and troubleshooting purpose. All right, so if we can do that, how exactly it helps? Well, it detects network attacks, okay, and leaks, okay, or suspicious activity. All these things could be identified with the help of packet capture. So it's helpful in troubleshooting application performance issue by analyzing data flow, useful for debugging slow network performance, drop packets, or routing failures. So it's a wonderful tool. So when should we use it? Well, if you suspect a security breach, okay, or maybe unauth traffic, like DDoS example we took. So we will use packet capture when troubleshooting an application that is slow or failing to connect. Like not all are facing this. In IP flow, everybody was facing this. Web slow, everybody was facing web slow. IP flow, like users were unable to access the website. All were facing slow. Here, few are facing slow. Rest are fine. See the difference? So when investigating data packet loss or network latency issue, packet capture, deep dive, right? So how do we use it? We need to go to the same network watcher, select the packet capture, choose the target VM, specify the storage location to save the capture, set filters like capture only HTTP traffic on port 80, click start, packet will be recorded for analysis. So here on the network watcher, we have packet capture. We click on packet capture and we can add all that information, capture location, the storage we talked about, and the filters, capture only HTTP traffic, and all, like here we have target virtual machine, packet capture name, all the information, continuous capture is here. And once we start capture packet, it will have everything on our storage account. All right, now the another tool under Network Watcher is called Next Hop. Next Hop. So to understand this, let's say there is a new application deployed on Azure, okay, and this database, let's suppose, is on premises, okay. We are just trying to make this scenario Azure, and this is on prem, and there is a VPN connection in between. Just try to understand. I'm just showing these three VM, and they are talking to each other from Azure to on premises through VPN or express route. Doesn't matter. There is a connectivity. That's the point. Now, let's suppose your company says, or your people, your users say they're not unable to connect, fails to connect to the on-premises database. So how could you see what is the wrong? So if you try from here to reach here, we need to see what is the next hop, because if this is the VM, the traffic will go out of the VM to the subnet, to the INSG, to the firewall, to the VPN gateway, and then reach the on-premise. There are multiple things it will go through, multiple hops it will go through. So next hop, this tool shows that the packet are not reaching the VPN gateway and are instead being sent to the internet due to maybe a wrong UDR or misconfigured effective routes, or maybe blocked by the energy, things like that. So you update. If it is UDR, you update the table to ensure the traffic to on-premises resources goes through the VPN gateway, right? And if you see traffic is not going anywhere, you check the energy. So the application will start working once you figure it out where is the problem, why it can't reach to the on-premises, right? So We need to use next hop when troubleshooting network routing issues, especially when using VPN, express route, or complex network infrastructure architecture. So, what? For routing issues, right? Now, let's try to understand in detail. So, after understanding this scenario, this example, if we ask you what it is, well, we can simply say next hop helps analyze network routes by showing the next network device or hop that a packet will take to reach its destination. Okay, trace route that we do, right? That's what it is. It will help us because you can't do trace route here. So this tool, this feature of Network Watcher will help us. And how exactly? Well, it helps us understand if a packet is routed correctly or if it's being sent in the wrong direction. Diagnose routing issues in complex Azure networks or firewalls. If it is very complex infrastructure built by somebody else, maintained by someone else, and when you joined the company and you found the issue, then you need to know what is the next hop, right? And when should we use it? When traffic is not reaching the destination. Traffic not reaching destination. Expected destination. Check where it is reaching. Next hop. All right, now you need to go to the same location, Network Watcher, next hop, and fill the source VM destination IP address and show which network device is the next hop. You can check. Now we have another important thing, which is, I could say, fifth, which is NSG flow logs. And we all know what is NSG. We have a pretty decent video on NSG in the same series, which is Network Security Group. So let's take an example to understand this or other scenario, like unusual network activity is detected on a virtual machine. Suppose this is a virtual machine and we have seen some unusual activity. So your security team notices that a DB server VM is receiving traffic from unknown external IP at odd hours. Ideally, now forget this scenario on-prem or everything is on Azure now in this scenario. Now, ideally, the only traffic which should be coming to this website should come from here. This is the only route. In ideal situation, we might have application gateway, traffic manager, front door, but just to understand these feature, traffic should come through web. These are not allowed for the external traffic. DB should be allowed only for app and app should be allowed only for web. Right. But the issue is security team notices that database server is receiving traffic from an unknown external IP at odd hours. You suspect a potential security breach, but don't know which firewall is allowing the traffic. So you gotta use NSG flow logs to check who is connecting to the VM, from where, and on which port. You find that maybe an outdated NSG rule is allowing inbound connections from any IP address on port 1433. So these flow logs will help us understand that. Now, if I need to define it, what it is, well, NSG flow logs provide a detailed log of all traffic that is allowed or denied by network security groups. Because we have NSGs on all the subnet. We have NSG here, we have NSG here, we have NSG here. Right, and how does it help? It helps to track trying to access your resources, uh, and from where. Identifies potential security threats or malicious access attempts or misconfigured NSG in simple terms. Right, when to use it? To analyze why a VM or application is not receiving traffic or receiving from unauthorized access. And you need to go to the same place to use it. Go to Network Watcher, NSG Flow Logs, choose the NSG associated with your VM or subnet, enable flow logs and specify storage location for logs. Use Azure Monitor or Log Analytics to view and analyze traffic patterns. And trust me, I have seen there are hundreds of rules on the NSG. So that's the reason you don't know which one is, blocking or allowing. So these tools will help you. It's not like in a like people use in their lab one or two or three rules, or a small environment they have small rules. You will find hundreds of rules on a single NSG. All right. What is the next? Next is traffic analytics. Traffic analytics. Well, as the name says, we are going to analyze traffic. How? Let's take this simple scenario. Your cloud bill is unusually high, and you find out through the bill it is due to excessive data transfer. Now, your company notices an unexpected surge in network bandwidth cost on the monthly Azure bill. You need to figure out which resources are consuming the most bandwidth and whether this is normal. So, what you're going to do, you're going to use network analytics. You're going to use traffic analytics in Network Watcher. And the dashboard shows maybe a single virtual machine is transferring large amount of data to an external IP, okay, which is unexpected. Now, upon investigation, you realize that a misconfigured backup job is sending full database backups every hour instead of incremental backup. Okay, your problem is solved. So you adjust the backup policy to only send incremental changes, reducing data transfer cost by 80%. So whenever cloud is in the picture, you think from the cloud perspective, not from your legacy or on-premises mindset, because everything has a cost associated in cloud. That's the reason we need governance all the time. It's a pay as you go. If you're doing something, you're paying something. So if you're coming up with the legacy or on-premises mindset, you might learn later when you have a huge bill or some security breach happen. You would not believe I have encountered customers which have like no security and running multiple VMs, attaching directly public IP to the VMs. When you talk to them, you figure out they have this understanding. If you're running anything on the cloud, it is by nature it is secure. No, it is not. All right, I have seen customers coming with the huge bills because they have created their infrastructure with a different mindset rather than cloud mindset. Anyways, let's come to the point. So, what it is? Traffic analytics uses AI powered insights to analyze and visualize network traffic patterns across your Azure environment. It will show you, right, on the dashboard. So it provides deep insights. What it does, it provides deep insights into network traffic, including trends and anomalies. It helps optimize your network performance and by identifying bottlenecks, detects suspicious traffic. So when should we use it? To understand which resources are communicating the most, optimize cost, detect security threats like brute force attacks or DDoS attempts. All right, and the same place you need to go to use traffic analytics, network watcher, traffic analytics. Enable your traffic analytics for your NSG flow logs. Set up Azure Monitor Log Analytics as the backend. Use dashboards to analyze trends and detect anomalies. All right. So these are some wonderful features that Network Watcher provides, and we should be using it whenever there is a requirement. Now, if you're wondering, it's fine. It seems like a great tool from network monitoring and diagnose perspective. What about the cost? Well, let's see what about the cost. And This is effective security rule. We have already seen this on our NSGs, which will allow us from where our traffic is going. If you remember when we talked about service endpoint, when we talked about next hop firewall, we shows network security rules. It is there. And if there is an issue with your VPN, you can simply utilize VPN troubleshooting, and it will start troubleshooting once you click on the start troubleshooting after providing the information and storage account, and it will give you information if there's an issue with your VPN, right? This will give you the topology of environment. So this is what the network watcher all about, and let's check the pricing. This is network watcher pricing page. Now you'll find something interesting here. Because monitoring and diagnose means a data. There's a hell lot of data, right? So if we have network flow logs collected, which is NSG flow logs, you'll see 5 GB per month is free. However, afterwards there is a price. Same goes with the virtual network flow logs. 5 GB per month is free. Afterwards there is a little charge. Now, diagnostic tools that we have, 1,000 checks per month is free. Afterwards, there is a check like IP flow is a diagnostic tool. If you run it once, twice, it is free, but it's more than 1,000 times. You don't worry about the payment. You should worry about your network if it is more than 1,000 times getting interrupted, right? Then connection monitor, we have already talked about 10 tests per month is free, and afterward there is a cost. So there is some cost associated with all traffic analytics. You see, here is because for analytics you need to get the traffic in, right? So accelerated processing at 10-minute intervals. This is 3.5 per GB processed. So the point I'm trying to make, you would have a network watcher created by default that we gave you example at the beginning. This is your Azure. If we created Azure SQL PaaS, there is a no network watcher, but if you create a VM, network watcher instance created automatically. There is no charge for that as of now, but if you start utilizing the diagnostic tools, started collecting the logs, there is a little charge involved for each of it. There is a default free for everything, but once you cross it you need to pay for it. But if you are crossing the default one, it seems you need to restructure your network for sure, or it is too complex to maintain. Anyways, I hope this was interesting and you enjoyed watching this video on network watcher. You learned something new today. Well, thank you so much, and this is the last video in the series, and we'll be starting the security series, like SC series maybe, next, starting from SC 900 version 2. Version 1 is already there, but it is pretty old, like 3 years or more in this channel. So we'll start with SC 900 V2, then we'll go with SC 100, 200, 300, 400. Or if you have something else in your mind and you would like us to cover, you can give us a comment. Or we'll be starting the realistic scenarios or presentations or communication with the customers, just for the sake of knowledge, for the people who wants to get into the cloud, for the people who are new in the cloud and they don't know exactly how cloud works. Because I started my journey from like as a cloud engineer, then escalation engineer, migration engineer, then cloud consultant, and then architect, and then senior solutions architect, and then principal architect, working in the pre-sales now. So I've covered the entire journey from cloud engineer to pre-sales, or you could say the journey of any deal, any cloud deal that comes in your company, from back to the top. Now we are getting the deal from sales to pre-sales to solutions to architecture to delivery and delivered it or under the support. Earlier when I was in the engineering, so I was getting the deal, like we are delivering the deal. So we have covered the entire pipeline of it, how exactly it works. So maybe we'll be talking about certain things which will help you understand how exactly things work in an organization from cloud perspective. Till then, thank you. Thank you for all the support. Thank you for watching.